What? I have to make you. Oh, yeah, make you co-host. Yes. Okay. Now, see if you could just press share screen and then select what you want to share.
Good evening, all. I'm How are we doing today? Hello. Okay, so we're here with
Well, I see you sharing something.
Okay, that's fine. Now, Miguel, send me the presentation itself, the module 4.
All right. Hold on. Hold on.
You can still see my screen?
But barely, only the top part.
You can see it now, right?
Only a small piece of your screen. That's the top part.
You can see it now?
No, only the top part.
You can see it now?
Hold on. Yes, hold on. Yes, getting view. Yeah. I can see it. It's a little bigger now. Yeah, I can see it now.
Okay. So when they come in with the... Hi, Ms. Pender, good evening. How are you?
Good evening. I am well. I'm driving, trying to get home quickly.
Okay, Ms. Pender, take your time, Ms. Pender, take your time.
Yes, I'm not speeding.
Okay, all right.
Not speeding. I'm almost there, about 7-8 minutes away.
Okay.
Yeah, okay, good. We can see your screen. I mean, they can share along. I sent them the values as well, so they can follow along as long as you go with your screen.
Okay, fantastic, Miguel.
All right.
All right. Great, you can still see it, right?
Yep, you can still see it. Good.
Good.
All right, so if you need me, just give me a shout.
Okay.
I'll be right here.
All right, well, why? I mean, you can listen in or you're recording, right? Just blank out your screen.
No problem.
Okay. Kermit Ferguson, Mr. Ferguson, how are you? And Mr. Ferguson, are you there?
Yes, I'm here. Good
Okay.
afternoon.
Good afternoon, sir. Thank you for joining us. You weren't with us the last time, am I correct?
No, I wasn't there last week.
All right, tell me a little bit about yourself while there's only us here, sir.
Kermit Ferguson. I work at Gateway Ascendancy.
Where is it that you work, sir?
Gateway Ascendancy.
Oh, tell me a little bit about that. That's, I mean,
Yeah, so we deal with distress mortgages, and specifically from Scotia Bank and some RBC as well, some RBC. But yeah, we deal with distress mortgages. We try to restructure them to help our clients be able to pay and service the debt better. And we also sell properties as well.
you sell, I'm sorry, you sell what?
And we also sell properties and homes as well.
Huh?
Yeah. That's basically what we do.
Okay, are you affiliated with, was this a part of the bio that happened of Scotia Mortgages about 3 years ago?
Yes.
Okay. I'm just want to get in line with you. Okay, so all right, sir. And how long have you been at Gateway?
A little over 3 years now.
Okay, where were you before that?
Securities Commission.
Oh, Lord. What you do at the Securities Commission, sir? What did you do at the Securities Commission?
I was a junior officer in the authorizations department. I'm young, so I'm not, I don't have a bunch of employment history.
We just having a conversation. I'm sorry if I made this sound like this is an interview. That was not my intent.
But yeah, I was there at some point as well.
Okay, all right, excellent, my brother. You building your resume, man.
So
I mean, and I applaud you for that. What made you think to come and do the CIFP? I gotta get.
I did it. I just did it as I just saw it as a way to learn something more. Okay. And I mean, it can't be taken from me. So I just thought as extra learning experience.
Okay, fantastic. I mean, you're in the finance field. I mean, it's not a direct tie-in, but I mean, it will help you, I think, in performing your duties and just understanding the world of finance better.
Yes, sir. Yes, sir.
Excellent, sir. I applaud you and I welcome you, sir. Now, in our first class, I don't know if you reached out to any of your classmates to know where we got up to.
No, I wasn't updated.
Right.
I was not.
No, but we're basically going through part one and doing the future value, present value of our lump sum. So you didn't miss a lot, sir. And I was just familiarizing them with calculating that, and we began to learn the use of tables. I mean, there are formulas in which to calculate it.
Mm-hmm.
And I mean, for your own edification, you can go through and understand how the formulas are constructed. But there is a quicker way, and it allows you in the exam to use what they call tables.
Okay.
And that basically, and I know you're familiar with it, doing mortgage interest and everything like that. So we got up to the point last time of calculating, we did future value, present value, practice using the tables a little bit. And we are about to launch into multiple cash flows and then leading on to annuities.
The tables and the slideshow are in the slideshow.
I can show you it, sir. Miguel did it for me.
Okay. Now I just want to. I'll just double check later on. I just wanted to know if the tables were in the slideshow. I do
Can you
look for
see
it.
my screen
Good
now?
afternoon.
Yeah.
Hi, Ms. Woods. How you doing? Welcome.
I'm good. The tables are, Miguel sent them in his
Okay.
email. So I think he just sent them a little while ago.
That's right.
Oh, okay. Okay.
But here is a picture of the tables. The first one is the future value interest factor for a single cash flow. That's future value. Here is future value interest factors for annuity. That's a flow of equal cash flow, equal contributions, or what they call a level contribution. Here's the present value of a single cash flow and the present value of an annuity. These tables have been sent to you guys via email, as Ms. Woods pointed out a moment ago.
Mr. Donathan,
Yes.
just to let you know, I am on my phone via this class today. Unfortunately, I'm working late. So
Who are these slave drivers are causing you to work late, Ms. Woods?
well, I didn't want to, I'd at least be able to hear what's going on and understand. I tried to go over some of the calculations. A friend of mine actually assisted me with understanding the actual oh Lord,
Use of the tables?
not the use of the table as well as the formula.
Yeah, I mean, as you can see, the
I just wanted to understand it. So it's I actually understand how to do both of them, but unfortunately today, because I'm on my phone and just trying to at least listen in to what's going on, I'm unable to kind of see what's going on really. I'm just listening in.
Okay, ma'am. So if you have any questions, please feel free to ask. But as a note to all of the students, these classes are being recorded and Miguel can send them to you.
Okay. I will definitely ask him for the recording.
Okay, for this very express purpose that we understand you want to further your education, but at times all of us are adults and we have prior commitments or commitments that crop up due to family work, and that's why they're being recorded.
I understand because I'm working late and today is my son's birthday, so it's real jacked up right now.
Oh, shame. Oh boy, I know he
I know, right?
fixed right up. You gotta do some serious making up now.
I know. But he got one, at least one of his gifts this morning.
Oh, but I gotta talk to him.
I know you said to me that I sound really, really young, but I'm not as young as you think.
Really? Why do you say that?
Because even when people see me, they put me at a certain age category. I've been treated that way literally in my entire life, and the rest of the mostly females and males in my family actually. We just look really young. I have a 16-year-old, and no, I did not have her in high school. I was already married and everything, so that should tell you something.
Now, Ms. Woods, I'm going to tell you because you know how it is. Having children ain't no judging your age, cause
No, I agree with you, but there are some persons, like I was labeled until people really found out I was labeled as being a teen mom, and I wasn't.
anyway, we can go there. Let's okay. I just want the number of your son so I could teach him negotiating tactics. All right, so that's Miss Woods who's with me. Who else is with me? I see something, so it says C. Who is C who's popping up?
That's me, Mr. Donovan. Claudia, how are you?
Okay, Claudia, welcome. How you doing?
I'm doing well. How about you?
I am doing excellent. I am doing excellent, okay. Miss Pinder is also on the phone because she's in transit driving home. Ms. Woods is stuck at work on her son's birthday. And I have Mr. Ferguson here, who has joined us this week. So let's pick up where we left off. Were there any questions about last week? I hope everybody had a chance to do a little practicing. I think Ms. Woods, you told me that somebody assisted you with figuring out the formulas, right?
Yes, sir.
And you could see if you had to do them formulas really in an exam, how time consuming.
It is time consuming. It is time consuming. But I found like 1 or 2 questions also on the internet, and try to, I guess, break the question down as to if this question was asked to me, which one should I use, whether it's future or present. And I understand that with the discount, if something says a discount, that means you're using the present value.
That's correct. As soon as you hear a word called discount, that's present value.
Right. Because it shows it technically it'll be a lesser amount than what the figure is given. Yes. That's how I understand it.
No, and you're right. The way you approach it, you in a question, you're gonna look for keywords that will give you a hint. Discount is a keyword that relates to present value. You are absolutely correct. Other words like accumulate, that is a hint that this probably is a future value question. But you're right, you're getting the feel of it. And as I said last week, and as Ms. Woods do, go on to the internet, you can download practice problems. You're not in this by yourself. If you run into a practice problem that you don't understand, copy it, send it to me, and let's share it with the rest of the class. We work it out together, all right? This is a totally collaborative effort. Okay, let's go on because, it's almost past my bedtime and I just fade fast. Okay, today we're gonna do future value. Pardon me? I have another participant, Jay Johnson. Can you kindly introduce yourself?
Good afternoon, everybody. I hope that you all are well. I am Jay Johnson, and I am here. I am on the road driving, so I'll be muted for a little while, but I'm heading home now.
Okay, well, Mr. Johnson, before you can, you got your Bluetooth speakerphone on, right? You got your 2 hands on the steering wheel, right?
Yes, sir, on a foot.
Okay, all right, sir. Tell us a little bit about yourself, Mr. Johnson.
Okay, my name is Jeremy, actually, but everyone just calls me Jay. I am currently working at Bank of the Bahamas, the Bank of Solutions, or that's what they would like you to say or remember at least. Yeah, and I have joined the course because I feel like it is a great course and that would help me to assist my fellow Bahamians when it comes to financial matters or financial planning. So yes, sir.
Fantastic. What do you do with the Bank of the Bahamas, Jay?
Right now, I am a client relationship officer in private banking. So I basically provide all the banking services to high value clients or companies and give them a little bit of ease so that they don't have to actually visit a bank.
Wow, I need to speak with you, Mr. Johnson. But anyway, when you say high worth, but that took me right out the equation. I'm only joking, Mr. Johnson. Mr. Johnson, thank you very much for that brief bio on yourself. Welcome. Mr. Johnson, I don't know if you did any reading with regards to Module 4, but last week we covered basically present value, future value, and we learned how to use, well, we were introduced to how the formulas are constructed, but I told the class that during the exam, you wouldn't be expected to know the formulas where you have to memorize that formula and try to figure out the question. That's too much time, and those formulas can get very involved. Instead, if you have a financial calculator, you will be able to use a financial calculator. Barring that, there is something called tables. Time value tables. And Miguel sent out an email containing the basic 4, which is the future value of a lump sum, the future value of an annuity, which is a level equal amount of money put in at the same time intervals. We looked at present value of a lump sum and present value of an annuity. That is, what is the present value today if you were to put in lump sums over all that time period. So we got basically up to, we didn't touch on the annuity portion. We're gonna tackle that in just a moment, okay? So having said that, on module 4, part 1, I'm gonna pick up at page 7. And it's entitled Future Value with Multiple Cash Flows. Suppose you deposit $1,000 today in an account paying 7%. If 1 year you will deposit another 1,000, how much will you have in 2 years? Okay, so you deposit 1,000 today, and in a year's time, at the beginning of year 2, you're gonna deposit another 1,000. So conceptually, will somebody, Claudia, will you be able to tell me, basically without looking at the figures, what you should be looking for when you're tackling this calculation? You there, Claudia?
I'm here.
All right. So what should you be looking for? You deposit 1,000 today, and then at the beginning of year 2, you're going to deposit another 1,000. How much would you have at the end of year 2?
End of year.
Just break down the problem, Claudia. Don't try to do the calculation. That is not what I want from you right now. What is the first thing you would do?
Take into account the time, so it's like 2 years, you have to look at that. And then the interest rate, or you'd look at that column, and then you take into account the amount as well, so that you know what you're using. So you just try to gather all the information, and then you start doing the calculations.
Okay, that's good. Anybody else want to add to that, Mr. Ferguson?
I wasn't paying attention just now.
But that ain't a good thing to do in this class, Mr. Ferguson.
Yeah, I was not paying. I'll be honest. I was not paying attention just
Fair
now.
enough. I respect honesty.
But but I mean, if I didn't hear it exactly what Claudia said, but I would I guess if this is a futures table, then I guess since you're asking what it would be.
That is correct, sir.
Yeah, so I'm thinking that you go to the table and you look for 7% and 2 years. I don't know. That's what I'm thinking.
Well,
Go ahead.
yeah, yes and no. Jay, you want to take a stab at this?
Okay, so without looking at the futures table, just off thinking, I would think that we would try to find out the interest and the per diem,
Okay.
and then calculate it by that. Since we're not adding at the same time, but we're adding new things, and before the second year is out.
Okay, fair enough. All right. Couple of things you got to be aware of. First of all, the first $1,000, right, that you put in the first year, right? During the course of that year, at the end of that year, you would have earned interest on that first 1,000. That interest at 7% amounts to $70. This is only the first 1,000 now. So you're at the end of year one. At the end of the first year, you would get the $1,000 plus the $70 you would have earned on it, right? At the beginning, so at the end of year one / beginning of year two, you now have $1,070. To this amount, you then add another $1,000 of additional investment. So at the beginning of year two, you would now be investing $2,070, earning 7%. Does that make sense to everybody so far?
Yep.
Okay. So it is not only the $2,000 you injected, but what you have working for you is also the $70 that you would have earned on interest on your first initial deposit. So at the beginning of year two, you now have $2,070 that you're going to invest at 7%. Okay? Now the way, who is sitting at their desk right now? Who is looking at who can look at the tables? If I were to switch my screen, who is actually seeing my screen right now? I know Jay is driving. Ms. Woods is at work. Mr. Ferguson, can you see my screen?
Yeah, I'm trying to so I can pull up the tables.
No, I'll switch the tables. I don't want you. I just want to know if you can see my screen.
Yeah, I can see the screen.
Okay, and Claudia, you can see my screen or you're at work?
Okay, I'm seeing the tables now.
No, I want to know. I want us to do this together. I don't want you to do it apart because now that I have a thing I want to show on the screen how to use the tables. Who can see my screen? I'm just trying to figure out who's driving and who I got with me.
All right, I can see your screen.
Yes,
Okay,
well.
Cindy, you home yet?
Yes, sir, I'm home.
You in front of your computer?
Yes, sir, I am.
Okay, so I'm going to switch. It's a future value thing. So here it is, the future value interest factor of a single cash flow, because these are actually two single cash flows. So I look at 7% for 1 year, for one period. You see this? 7%, one period. The intersection is 1.070, okay? Now, if you multiply that by 1,000, now you get 1,070. Remember, whatever the factor is, you multiply it by the principal amount you're working with. Is that clear to everybody who can see my screen? Mr. Ferguson, you can see the screen?
Clear.
Yeah, I can see the screen.
Okay, so what you will do, the first year, you would have invested $1,000, right?
Yep.
Okay, so you would then say, look at 7% for one period, because the periods we're talking about here is a year. You get this factor of 1070, and you multiply it by 1,000, it comes up with 1,070. Good?
Yes, sir.
Good.
In the second year, you add 1,000 to it, so now you're working with $2,070. Yes?
Yep.
Everybody know where I got that, right?
Mm-hmm.
Now, the tricky part about it is this question is tricky. You would think reading this, you would say, okay, I'm going to take this amount and then I'm going to go to 7. We know it's 7%, but that 2,070 is invested for how many periods?
For 1 year.
That's correct. So the factor you're using again is the 1070.
Okay.
So now it's the 2,070 multiplied by this factor of 1070. Good stuff. Good stuff. All right. So they go through all this working. If you can see my screen, they said this particular problem is relatively easy. At the end of the first year, you will have 1,070 plus the second 1,000 you deposit for a total of 2,070. You leave this 2,070 on deposit at 7% for another year. At the end of this year, it is worth, and they go through the calculation, the 2070 times the factor of 1.07, and you get 2,214.9. Okay? Now, they're going to switch. From future value, they're going to do a present value problem. Very often, we need to determine the present value of a series of future cash flows. As with the future value, there are two ways we can do it. We can either discount back one period at a time, or we can just calculate the present values individually and add them up. Okay. Suppose that you needed $1,000 in 1 year and $2,000 more in 2 years. If you can earn 7% on your money, how much do you have to put up to date to exactly cover the amounts in the future? In other words, what is the present value of the two cash flows? And I'm going to use a term here, they don't put it in discounted at 7%. So Claudia, I know you like that. I factored in that word discounted. The present value of $2,000 in 2 years at 7% is 2,000 divided by 1.072 or 1,746.88. Now they're dividing this. I don't want you to do it this way. I'm gonna go back At this time, I'm gonna use the present value tables, okay? Okay, so I go down and I find the present value.
Present value for the cash flow, right?
Yes, sir. So the present value factor of $1 at 7% for one period is 0.9346. Does anyone have a calculator there? Is anyone close to a calculator?
I have a calculator.
934.60 would be the present value at 7%.
No, hold on. I'm doing something wrong. Hold on. I don't want the present value of an annuity. I want the present value of a single cash flow. This one, right? 7%. 7% for 1 year is 1.2. But the $2,000 happened in year 2, right?
Hold on.
Hold on.
Yeah.
Let me see something.
Yeah, I'm not seeing that.
Yeah, because I'm in the present value for single cash
Correct.
flow. And
Right.
I'm seeing 7% for 1 year is 0.9346.
That's
Yep,
for 1 year. The present value.
Yeah, for 1 year.
Mhm.
Do it for 2 years. Drop.
So then that would be 0.8734.
0.8573.
No.
What is
2
it?
years is 0.8734.
Right. Now multiply that by 2,000 and what do you get?
So that's 1,746.
46.80.
Yeah.
Okay, that's fine. So we now have the present value of 2,000 discounted back for 2 years. The second part of the problem, $1,000 is discounted back for 1 year. Remember, there's 2 cash flows. You need 1,000 in year 1 and 2,000 in year 2. They took the longest period first to work out what will the present value of the 2,000 in 2 years be. That's 1.746. What would the present value of the $1,000 be 1 year hence?
So it would be the 1,000 times the 0.9346.
And then what do you get with that to be?
934.60.
So to find out the total money that you have to invest today in order to come up with these cash flows, you would add the 1.746.88 plus the 934.8, coming up with $2,681. You would have to invest today in order to generate. You would have to invest today at a rate of 7% in order to allow you to get $1,000 in 2 years, in 1 year, $1,000 in year 1, and then $2,000 at the end of year 2.
And what's the final answer?
$2,681.46 you would have to invest today.
Okay, so I got that. I'm just understanding, you said that we would take the longest period first. Is there a reason why we would calculate that
No,
first?
it doesn't really matter. It's whatever. It was whatever.
Okay.
Okay, Raquel. I'm teaching class as a urgent. Okay. It doesn't matter what you do first or what you do second. It really doesn't matter.
Sorry, the visit answer was $2,681.40.
Yes.
Okay, all right. Just trying to make sure I work it out.
Yeah,
Okay.
that's fine. That's fine. But that's what be here for. You take your time.
So that answer. So this tells me that there's how much I need to put in. This was I would have need to put in if I wanted to get that amount of money 2 years ahead.
But if you wanted to generate those cash flows, all right, and you know that in a year's time, let's just say the child going away to college. In a year's time, you're gonna have to come up with $1,000. All right. Then at the end of year 2, you're gonna have to come up with another $2,000. Okay. It's asking you what amount you would have to plumb down today in the bank if they were paying you 7%, so that you'd be able to take out the 1,000 in a year and comfortably afford the 2,000 in 2 years without no worry. Does that make sense to everybody?
So I have to put, so okay, so 2 years in advance, basically, right? This is a futures question, right? I understand.
Yeah, I mean, I
Well,
don't
not a
know,
futures, but
it's not a futures question.
but you understand what I mean? Like this, trying to say, okay, Kermit need to put aside $2,681
Today,
today in order for me to really say I want to take out $1,000
in a year,
in a year, and $1,000 for following year.
$1,000 in 1 year from now, and then $2,000 2 years from now.
Okay.
Are you with me? I mean, if it's not making sense to anybody, please speak up. Don't think you can figure it out later. Let's go through it till everybody understands it. Please, don't feel bad or anything. You paying the money for this course. I am here to make you understand it. Do I take silence meaning that everybody understands it?
So far, so good.
Okay, here is what it is. Kermit, we take out, okay, all right. Let's check it. Let's check to see this is indeed 2006. Now, Kermit, what they're gonna do is take the 2,681 and do the reverse to say, okay, if this is the amount you say, Mr. Don, prove it by showing me. And let's do the reverse. Let's do the future value portion of it. So we know we got 2,681.46 we put in the bank. Let's say at the end of year 1, with that earning 1.07%, let's go to now back to the tables, and we're going to go to the future value of a single cash flow, 7%. 1 year period, the factor is 1.070, right? Kermit, take the 2,681, whatever that you would have to plumb down today, and multiply it by the factor of 1.70. What do you get?
So it was 2,800 how much?
No, 2,681.46. 2,2681.46. Multiply that by 1.07.
So that gives me 2,869.16.
Okay, so that's what you get at the end of the first year when this investment matures. Take off $1,000. What's left?
1,869.16.
Right?
Yeah.
Okay, take that 1,869.16 and multiply it by the factor again of 1.07. What do you get?
2,000.
Okay, so there's your cash flow. You took out the $1,000 in the first year, and then the second year, after this thing matured, you got the $2,000 you needed.
Wow, okay. Because I wasn't seeing it at first, but okay, I see it now.
You got it? You got the concept?
Yeah, I see it now.
Now, present value is only the reverse of future value. This example illustrates that the present value of a series of future cash flows is simply the amount that you would need today to exactly duplicate those future value cash flows for a given discount rate. An alternative of calculating present value for multiple cash flows is to discount back to the present value one period at a time. For example, suppose we had an investment that was going to pay $1,000 at the end of every year for the next 5 years. To find the present value, we could discount each of those $1,000 at the end of every year for the next 5 years. Do you understand what they're saying there? You take the $1,000 for year one, discount that back to the present value. You take the future value of 1,000 that you need in 1 year, discount that back to the present value, you find what that's worth. You take the $1,000 from the second year, discount that back for 2 years at to the present value, and you'll see. Does everybody, I know some people are still driving, are you following my screen?
It's not on full screen.
It's not
So
on, it's not on.
It's not on full screen because we can still see your what are they called on the left?
This?
We can see all of, yeah, we can see all of your slides on the left.
Okay.
So if you put it in full view, then we should be able to see the writing much bigger. There you go.
Okay. All right. This is the concept that they're after. In year one, here's the $1,000. You discount that back. For one period, you get the present value amount of 909.09. Take the $1,000, discount it back for 2 years. 1.12 is a factor, and you get 826.45. And so forth. And then at the end of it, you add all these up. Total present value, 3,790.79. What that is telling me, in order to generate $1,000 every year for the next 5 years, I have to put in today 3,790.79. Everybody with that? Now, there's an easier way to do that. This is 1, 2, 3, 4, 5 calculations. Yes? Invest. So this is what they call a level cash flow. Because the cash flows are equal and the time periods are equal, each occurring in a year and each value being $1,000. That's what they call a level cash flow. Investors and lenders often encounter situations where they have multiple cash flows that are all the same amount. For example, a very common type of loan repayment. Who does work for the Scotia? Wow, that's you, Mr. Ferguson, right?
Pardon me?
You just work in Scotia, right? For the mortgages and I think you work at the entity that took over the Scotia book, right?
I work for the company that took over Scotia stuff, yes.
Okay,
Yes, sir.
I mean to be funny. You know, I over 50, so my memory ain't that good. For example, a very common type of loan repayment plan calls for the borrower to repay the loan by making a series of equal payments for some length of time. almost all consumer loans, such as car loans and home mortgages, feature equal payments usually made each month. A series of constant or level cash flows that occurs at the end of each period for some fixed number of periods is called an ordinary annuity. A series of constant or level cash flows that occurs at the end of each period for some fixed number of periods is called an ordinary annuity. All right. Present value for annuity cash flows. Suppose we are examining an asset that promised to pay $1,000 at the end of each of the next 3 years. The cash flows from this asset are in the form of 3 $1,000 annuity. If we want to earn 15% on our money, how much would we offer for this annuity? Now hold on, let me see if these future values got 15. Yeah, they go to 15%. Okay. All right. Let's look at this. From the previous section, we can discount each of these 1,000 payments back to the present at 15% to determine the total present value. Then this example goes on to do it manually. And the answer they come up with is 2,283.22. In other words, what is the amount we have to put up today in order to generate cash flows of $1,000 for the next 3 years if we are paid 15% on that amount? It goes through it. Now, this is what we're gonna do. I'm gonna go to the present value of an annuity factor table. Present value tables, this is the one I want. Present value interest factor for annuity. 15% for 3 periods. Okay. Wait a second. Present value annuity factor. Oh, I got you. Okay. So 15%, right? For 3 periods, the factor is 2.3216. Everybody can see that? The intersection? I'm sorry, that's wrong.
Is that annuity?
Right, 2.382. Let me do something here. 15% for 3 periods. The factor is 2.2832. Everybody can see that? Everybody can see my screen?
Yes, correct.
So what we'll do, we'll take the $1,000 that we need, that is going to be paid, and multiply it by this factor. Ms. Pender, what do you get?
Okay, so times 1,000, $2,283.20.
Okay, let's check what they say here. 2,283.22. Right, Ms. Pender?
Yes, sir.
And guess what we didn't have to do?
Go line by line, year by year.
All we needed was this, what's the rate, and how many years? 3 years, $1,000, 15%.
Yep.
And then we go to the tables. I look up 15%, 3 years. I get the factor, 2.2, and multiply that by 1,000.
And so this question, basic to this answer, basically is saying that we needed $2,000 to $283 to invest today in order to get those funds $1,000 every year for 3 years, right?
That's exactly what that is. Yes, sir. Okay? Most situations have a large number of please let me just stop here and tell you guys this. Only way this works is because all of these cash flows was the same. If you had one of these cash flows that was different from 1,000, you can use that. You'll have to go back and discount every one of these individually.
Oh, I did it. I got the same thing.
What did you do and what did you get?
Oh, I did it year by year.
Yeah,
Or period
you're
by
surprised?
period. Yeah. Hey, now.
One thing about math is not subjective. It is a science.
I know, right?
Okay, so you're saying that if, let's say, year 2 was $1,008 and year 3 was $1,100, then we would go to the table, and for year 2 we look for 15% for 2 years, right? No, 15% for 1 year, because that's still a 1 year period. But it'll be times the 1,080, since the cash flow at that time is 1,080.
You got it.
Okay, I just want to make sure.
Hold on 1 second, guys. Bear with me just 1 second. I gotta. Okay, so we're pretty clear on that?
Yes, sir.
Okay, since most situations have a large number of cash flows making the above approach onerous. For example, a typical car loan calls for monthly payments over 3 or more years for a total of at least 36 payments. Let's look at a quicker method. Since the cash flows of an annuity are all the same, we can come up with a very useful variation on the basic present value equation. It turns out that the present value of an annuity of N dollars per period for T periods, when the rate of return or interest rate is R or is given by annuity present value, here they start introducing the present value factor. But they're taking you through the formula. So this is the same PV factor that we calculated before. So that is what the tables are doing you. It is giving you the factor. Okay? Everybody
Okay.
with me on that?
Yes, sir.
Okay. Okay, Mr. Ferguson, you're gonna love this one. Let's do a practical example. You are a loan officer and Jay, you home yet?
Yeah, I radio listening.
I asked you that. I asked you if you home yet.
Yes, sir.
You in front of your computer?
Computer and phone. Yes, sir.
Okay, good. So you can see my screen now.
Yes, sir.
Okay, because I've been beating up on Ferguson. I can try you. I can let you do this. You
He
are
can,
a loan officer and you
he
are
can take that
trying.
one.
Go ahead.
I say he can take it.
No, no, you. Yeah. Okay, he done proved that. We can see it. You can take the chafing now. You are a loan officer and you are trying to determine the maximum amount that a prospective client can afford for a car loan. You have reviewed the prospect's budget and have determined that the maximum monthly payment possible is $500 per month. The going rate for a car loan is 12% per annum or 1% per month. Also, the maximum term is 36 months. How much can they borrow? Okay. Get a little tricky here. I can take you through this formula, but I can try to do it my way. Okay? The going rate for a car loan, whenever you got these questions that asks you about things being compounded or discounted monthly, quarterly, semi-annual, you're going to have to do some adjustments to the rate as well as the time factor, okay? If it is asking you for a monthly payment, you then have to take the rate and divide it by 12 because there are 12 months in the year, right?
Okay.
So you are going to find the prorated monthly rate by taking the rate and dividing it by 12, correct?
Correct.
Conversely, you are, because it's 3 years, all right, the term of this is 3 years, you are then going to find out how many monthly periods are in 3 years. So you do that by taking the years 3 and multiplying it by 12 because there are 12 months in every year, correct?
Yes.
So the same, okay, you with me on that?
Yes, sir.
So far.
Okay, great. Now, so you will see in this formula, here is the 1 divided by 1.01, which is the 1% per year. And they raise it to the power of 36 because there are 36 periods, right? And they divide that by 1. Now, if you were to use my tables, okay, you would go to this present value of an annuity. It's 1%, right?
Yes.
So you're going to look into 1%, then you go down to it just only goes up to 25. But you would go down, if they had more, to 36 periods and find the factor, okay? This don't go up that far. It only goes to 25, unfortunately.
So can we find the factor at the intersection of 12 periods at 1% and then multiply it by 3?
No, because compounding don't work like that.
Oh, yeah.
Okay? So let's just say they come up, you will see here that for 25, the factor is 22.0232, right?
Yes.
1% for 25. If you would go to 36, if this ran at 36, the factor would have been this, 30.11. You got me?
Oh, say
Okay.
it again. Say it again for me.
All right. Let's go back to the interest rate table. 1%, and if this had gone all the way down to 36 periods, it ended at 25. The factor, the present value factor for $1, 1% for 25 periods was 22.
Mm-hmm.
That factor. All I'm saying, because it doesn't go down to 36.
Okay, you wouldn't see it there.
Right. So what I'm saying to you is this factor that they came up with here. Come on for this. This factor of 30.11 is the equivalent of 1% for 36 periods.
36. Okay.
You got it? You take
Mhm.
that $500 and multiply it, you get $15,055. That's how much they can borrow. Okay?
Hmm.
Interesting.
Isn't it?
Very.
Okay. Now, a little bit different. Finding the payment. Suppose you wish to start up a new business that specializes in the latest of health food trends, Bush tea. I behave you not to write this. To produce your product, Island Blend, you need to borrow $50,000. The interest rate is 15%. And there are 5 years. The payments are all equal. So we need to find the relevant annuity factor and solve for the unknown cash flow. No problem. We take you through all of this, right? We're going to do 50,000. Interest rate is 15%. And there are 5 years. The payments are all equal. We need to find the relevant annuity factor and solve for the unknown. Fortunately, in this instance, they're using annual payments, okay? As I said, the monthly payments. So we go to this. First of all, okay, we're gonna go to 15%. 15% for 5 years, which is
3.352.
522. And they want the payment. Okay, so let's go back here. It's 50,000 divided by, what's the factor you just said?
3.3522.
Okay, so you take the 50,000 and divide it by that, and what do you get?
Oh, 14,915.58.
Okay, you can see my screen, right?
Yes.
And here's the answer, 14,916. You got 14,915.5, right?
Yes.
Okay. So you will have to make 5 payments of 14,916 each annually, or for whatever period. Clear?
$12.43 a month.
No, you can't do it like that. Be careful. Do not do it like that, because you see, if you just take that division and multiply that 14 by 12, you are not taking into fact the compounding
The
effect.
compounded interest.
Do not do that. Do not make that mistake, Val.
Okay,
All right?
sounds good.
Okay. Everybody else is clear? Kermit, what'd you say? Jay,
All right, right here talking, and I forget I got mute. Yeah, I'll just go through it again privately so I can make sure I know what we just did.
okay, all right. See that using those tables does all of this.
I have a question, on the factors, like how we can go to the table.
Claudia, come closer to your microphone. You sound very far away.
Is that any better?
Nope.
Oh boy. Okay, I'm closer to it now.
Okay, that's better.
Okay, so how they show all the workings of the 1/1.15 and then the 0.49. Do we have to know all of that, or can we just go to the table and get the factor of the 3.352?
Oh, Claudia, why you think I was showing you all this? You think you really gonna have time in an exam to do that?
I just want to make sure, because I'm like, I'll just use a table. So I'm like,
That's why I'm giving you all the tables.
I don't know what this 1.155 is, so.
I mean, they give it to you so you could understand the math behind the table. Okay? But no, you will be able to use either a financial calculator or you can use these tables.
Okay, understood.
All right? I mean, I wasn't trying to be cheeky with you. But when you think about the time you're gonna have in this exam, and y'all will find that y'all will be hard pressed to finish this exam in that allotted time. Take it from me. So every little leg up you could get in this exam, you take it.
How long is the exam? Do you know?
Whew. I think it's if Miguel, is Miguel still here around here someplace? I saw he was still on him at a, well, I think
You know how long it is?
I think it's about an hour. It's about 150 questions. I don't know. I don't want to frighten you because I've seen so many exams that I even take myself because I'm doing the series 7 right now. So don't let me confuse you. That is a question you need to ask Miguel when he comes back on. Okay?
Okay.
All right.
I have a question in reference to the tables you're going to use. I noticed that there are some percentages that are not on the tables, like 17 and 19 and stuff. Are we going to get questions like related to those type of, or just what's on the table?
I don't see it. I mean, they try to keep it as close to real world as possible. 15% is like a consumer loan. You pay 17%. Now, if it was left to me and he tells me now that we have control over the exams that's going to be written. If an exam was written that has 17%, I will make sure the tables go up to 17%.
Okay, understood.
Okay?
Thank you.
You're quite welcome. Future value for annuities. On occasion, it's handy to know a shortcut for calculating the future value of an annuity. For example, suppose you plan to contribute $4,000 every year in an IRA account, paying 7%. If you retire in 30 years, how much will you have? One way to answer this particular problem is to calculate the present value of a 4,000 30-year annuity at 7% to convert it into a lump sum and then calculate the future value of that lump sum as lump sum. Annuity at present value 4,000, it's 49,000, future value 49,000. I wonder, you see how convoluted that is. That's a lot of thing. You will not get anything like that. But even if you did, it's 30 years. Let me see. This don't go up to 30 years.
Child cost.
But
It
if
doesn't
I
go.
ask something like this, the factor table will go up to 30 years.
I think the table goes to 25, eh? Doesn't the table go to
Yeah,
25?
what I'm saying is, I was to give you a question like this, I would ensure that the factor tables will go up to 20, will go up to 30.
Okay.
All right? The effective annual rate. Quite often, the quoted annual rate and the EAR, effective annual rate. Quite often, the quoted annual rate and the EAR are not the same. For example, if a rate is quoted at 10% compounded quarterly, then the investment actually pays 2.5% every 3 months. Ms. Pinder, how did they get that?
10% divided by
3.
4.
3.
Yeah, 3. No, every 3 months. There are 4 3-months period.
Yes,
Don't confuse me now. So it's 10% divided by 4 equals 2.5, right?
you got it. Yep.
Okay,
So there are 4 quarters in a year.
there you go. So they prorated the rate.
Oh, wow.
Earlier, we asked, now they're leading up to something, so please pay attention here.
Where are we?
Pardon me?
I'm trying to look where we are on the screen.
Page 10.
Investments
Okay.
and investment products and market.
You with us, Mr. Ferguson?
Okay. So we're on scenario 1.
It says effective annual rate.
Effective annual rate,
Oh,
EAR.
okay.
All right. Earlier, we asked whether 2.5% per quarter is the same as 10% per annum. Ms. Pinder, what you think?
No, it's not.
Why?
The interest is compounded. So
All right. You have the effects of compounding. Scenario 1. We invest 1,000 at 10% for 1 year. The future value, y'all tell me what the future value is, future present. What's the factor from the table? Future value of $1,000, 10% for 1 year.
1.100.
So you multiply $1,000 by that, and you get $1,100. So you earn $100, right?
Correct.
What's the difference? Scenario 2. We
Sorry.
invest.
So this the 1.10 is 10% at 1 year, right?
Future value
Value, right?
of a lump sum.
No, but I'm saying is that the 1.10 that come from the chart at 10%.
Yeah.
Okay, yeah. I just trying to confirm.
I'm sorry, I should have gone to the chart. Sorry, but
That's fine. I just trying to confirm. Okay.
future value of a single cash flow, we did 10%, 1 year is 1.1. There it is.
Okay.
All right? And you multiply that by 1,000, there's 1,000, that's 1.1 is $1,100. Good? Scenario 2. We invest $1,000 at 10% compounded quarterly. What's the first thing we got to do?
Work out that rate and how they compounding it.
Okay, good. How do you work out the rate?
10% divided by 4 quarters.
And the rate is per quarter is
2.5%.
rate. Now, and it's for 4 periods, right?
Yes.
Yes, 1/4 times
All right,
4.
so when you go to the future value, right? Future value of a single cash flow. Here is 2%. I don't have 2.5. But what is the period that I should, let's just say it's 2%. What is the period or the number of periods I should be looking for to find the factor?
4.
4 periods.
Ah! Now I want somebody to add these two factors between 2 and 3%, 1.1041, add 1.1593 and divide by 2.
No, you said it's 4 periods, right?
Yeah.
So that's 1.0824
Right.
and
Okay.
1.1255.
Added to 1.1593.
That's period 5, you know. That's
Oh,
at the
I'm
5,
sorry.
yeah, yeah.
Yes, my mistake. You're quite correct, sir.
Okay. You're saying add the 1.0824 plus the 1.1255 and then divided by 2?
Right.
Okay.
What factor do you get? What's your answer?
$1.10395.
That can't be right. Hold on 1 second. Let me go back to the present value tables. 1.0824 plus 1.1255. Add those together and divide by 2 and you come up with?
1.10395.
Oh, okay. Let me see what they got here. Okay, 1.10395.
Yes,
Okay, multiply that by 1,000, what do you get?
1103.95.
Okay, go to the answer here on the thingam, and what is the answer?
It's saying 1103.81.
Okay, the point they're trying to make, with scenario 2, we earn an additional $3.81 in interest. So the EAR is actually 10.381%. Couple of things I did there, observations. I'm not telling you it's exact science. I did not have a factor in the interest rates factor. I did not have a 2.5%. So as a workaround, I bridged these two and found the average between them. You with me on that?
Yes, sir.
All right. The other thing is, how do you find out what the rate is? The actual rate is. They say is 10.381. How do we know that to be true?
Mm. I know some decimal points got moved.
No, what I want you to do, take the answer, which is 1103.81, and divide it by the original principal of 1,000. What do you get?
1.10395.
And you take off, to turn it into an interest, you subtract 1 and then multiply by 100. 10.381, right?
Yes.
Okay. EAR, which now, okay. EAR equals 1 plus the quoted rate divided by N multiplied by n minus 1. That's the same thing y'all did. N equal number of times and interest is compounded. Comparing different investment alternatives. This can be fun. There are 3 investments that require the investor to invest $1,000 for 5 years. But the interest rate and compounding period differs in each case. Investment 1, 12% compounded monthly. Okay. Investment 2, 12.4% compounded quarterly. Investment 3, 12.8% compounded annually. What they asking you to do, what is the best investment alternative there? Let's do it quickly. Let's just say you had $1,000 and you had an opportunity to invest it for a year with interest rate compounded 12% monthly. What's the factor? What would I, oh God, I lost the page now. What would I do?
At 12% compounded monthly, we wouldn't divide that 12 by 12, because since it's 12 months, so that'll be 1% per month.
Hold on, let me catch up with you, sir.
All right.
My thing scrolled a lot faster than I was ready for it to do. Okay, here we are. Okay, what were you saying, sir?
I was saying if it's compounded at 12% monthly, we would divide that 12%. 12. Okay, now I ain't sure no more.
No, you were right. You were on the right track. Go ahead, continue.
I was because it's 12% monthly, I would divide that 12% by the number of months in a year. So that was 1% monthly.
Okay, let's go to the future value. We only doing it for 1 year, so in this instance, future value of a single cash flow. So it's 1%. How many periods?
12.
12. You're correct. So multiply 1,000 by 1.1268. What do you get?
Okay.
What's your
1126.80.
Okay, write it down. Okay, write it down someplace. Everybody got it recorded someplace?
Mm-hmm.
Let's go to the second scenario. Okay, second scenario. 12.4 compounded quarterly. What do you do?
$12.4 divided by 4.
Okay, and what do you get?
3.1.
Okay, 3.1, let's go to the interest table, 3.1, which in this case, I'm gonna say 3%, okay?
Okay,
And how many periods?
4 periods.
You get a factor of 1.1255. Multiply that by 1,000, what do you get?
Sorry, how did you get?
3%.
Ah, sorry, okay, yeah. 1.1255.
And when you multiply it by 1,000, what do you get?
You get 1125.50.
Great. Record that. Now, let's go to the third scenario. 12.8 compounded annually. Pretty simple, right? How many periods?
One.
Okay. So let's say 12.8, that's closer to like 13. Put down 1.130 and multiply that by 1,000.
1130.
Okay. Based upon the numbers, what appears to be the best investment so far?
The annual
Okay.
compounded annually.
Okay, let's see. Now, 1,000 times 1.031 times 20 times 1.8415. Is that the factor we got? Investment 2. Investment 2 was 12.4 compounded quarterly. What did we get? What's the factor we got?
3.
Huh?
Sorry, we got a factor of 1.1255.
Oh. I did y'all wrong, guys. I did something wrong. It's for 5 years, not 1. You got me?
Okay.
So the concept is the same. You would work it the same, but instead of the same way you did and these things, my tables don't go besides these anyway. Monthly for 5 years is 60 periods. You got me?
Yes.
Okay. So if you would have a compound table that went up to 60, you would end up with this first factor of 1.8167. Okay, here's the 60. The other one was for 4 periods. That would have been 20. You would end up with 1.8415. And the last one was 1.826. So this turned out, scenario 2 turned out to be the better factor, the best investment.
Which was annually, right?
Quarterly.
Sorry.
That one was quarterly.
Quarterly.
So investment 2 is the best option. All right. Understanding loan types. Guys, I normally give a little 10-minute break, but what I'm going to do, I'm going to try press on and we're going to wrap up at 8 in the next half hour, okay? While the number of ways the lender and borrower negotiate the repayment of loan principal and interest is unlimited, we are going to narrow it down to the following 3 loan types. Pure discount loans, interest-only loans, and amortized loans. Pure discount loans. The pure discount loan is the simplest form. With such a loan, the borrower receives money today and repays a single lump sum at some time in the future. Such loans are usually short-term in nature. For example, A 1 year, 8% pure discount loan would require the borrower to pay 1.018 in 1 year for every dollar borrowed today. A common example of a pure discount loan is a treasury bill. T-bills, as they are called, have terms of 90, 180, 270, and 360 days. A T-bill is a promise by the government to repay a fixed amount at a specified date in the future. The future value is fixed, and the present value is calculated based upon the discount rate or yield to maturity. Example, assuming we have a 360-day T-bill with a maturity of 1 million and a yield to maturity of 4%. What is the present value? The present value is simple. 1 million divided by 1.04. Why? It's for 360 days, which is considered 1 year. The rate is 4%, written as a decimal, that's 1.04. So you will just take this amount and divide it by 1 plus 4% is 1.04. So it's 961,538.50. Interest-only loans. Our second loan type is an interest-only loan. As the name states, the borrower is obligated to pay only interest until the maturity date, when they must repay both the last interest payment and the full principal. A common example of an interest-only loan is a bond. The issuer promised to pay the lender interest over the life of the bond and then repay the full principal and last interest payment at maturity. Company ABC issues a bond which pays annual interest of 7% and matures in 10 years. At the end of years 1 through 9, Company ABC pays interest of $70 on each 1,000 of bond face value. At the end of year 10, Company ABC pays the 1,000 face value plus interest for year 10 for a total of 1,070. All right, let's go back. So we have a discount type loan, and an interest-only loan. Does anybody have questions on those?
So far, so good.
Oh, okay. You'll realize that all these things they talk about, our government issue these things?
Mm-hmm.
Good, okay. Amortized loans. With a pure discount or interest-only loan, the principal is repaid all at once. So on the two above, in one time, you borrow like $9, but at the maturity, you got to pay back 10. Borrow at discount. The interest only, the interest is paid to you, and then the borrower pays you back the principal. In other words, the principal is repaid all at once. An alternative is an amortized loan where the lender may require the borrower to repay parts of the loan amount over time. The process of paying off a loan by making regular principal reductions is called amortizing the loan. For those of you in the commercial banking sector, this concept is nothing new. Most mortgages require that the borrower pay a preset monthly/quarterly payment that covers all of the accrued interest since the previous payment, plus a portion of the outstanding principal. The payment is chosen such that the full principal is repaid by the end of the term of the mortgage. In other words, every monthly payment or quarterly payment is a blended payment, some representing principal and some representing interest. I am sure everybody is familiar with that. Okay? So that brings us to the end of part 1. Part 2, I'm going to ask that everybody reads, because part 2 is less calculation. So I'm going to go faster through that. Okay? Are there any questions so far?
No, sir.
We be good?
For me, I think I'm still struggling with identifying which chart I should be referring to, but I'm sure with more practice, I should get it.
All right. Like I said, on the internet, you can look up practice questions. And it is not all of those combined together, coming at you all at once. They're concepts that with people who've been working with these concepts, no problem. For these concepts, new to a person, you gotta practice it. Please practice it. And you have my email address. If in between classes you wanna ask me a question or whatever, please feel free. I will answer you. Okay? Any other questions or comments? No? Well, guys, I guess God willing, I will see you all next week. Please enjoy the remainder of your week and stay safe.
Happy Independence as well.
Yes, happy Independence to all, so please be safe.
Take care, everybody.
Okay,
Thank you. Take care. Good night.
okay.
Okay.
Good night.